Thank you for the invitation introduction. And we are a new electron microscopy facility at NINT. Gas, we are not really directly related to any clean technique, but probably we will just here we'll just introduce ourselves about our facility and then the general capability, how to categorize and analysis of your in terms of nanomaterial and nano devices, and also some of the fabrication capability. My talk will be first will be the outline. The outline of my talk first will be the instrument we have, and also the categorization techniques and some of the fabrication. And I think I'm not going to talk too much detail into the techniques itself, but I will demonstrate them in some of the example projects we have been doing. And at the end, if I have time, I'll just show some policies and ways how to get access to our lab. We have, for the surface imaging, we have two SEMs, both from Hitachi. The 4800 is a very good high-resolution SEM, also has very excellent performance at low wattage for non-conductive material. And the image here shows a cross-section of a glass film from a glass group in NINT and UFA. The other, the 3000 SEM is an environmental SEM, can take sort of a wet sample and equipped with EDX detector, you can do some chemical analysis. Here shows a typical image of secondary electron image and also backscattered image showing the different material of an alloy sample. A dual column workstation from ZES has a very good field emission SEM column and also a gallium ion beam column. In theory, with a gallium ion, we can etch anything just due to a pure physical sparking. Equipped with a RIS lithography system, you can do the 3D nanofabrication directly. Doesn't involve any resist. Also with some other, say the EDX detector and also STEM detector, and also there was a gas inject system. You can do the deposition locally. You can also make a pattern with deposition. So it's a very good fabrication tool and also analysis tool. The other capability with the fab will be we can prepare the TM section, but in general from any of your material and the devices. Here are a few examples. On the top here is use a fab cut through the surface of a bag. From the image you will see it's really sort of photonic crystal structure. That's how we see the color of the bag. This bag is kind of bluish color. As I said, the gallium ion also produce unique imaging. Here you see a gallium ion imaging from tungsten tip. You see the contrast showed here is kind of domain contrast. You're not able to see this sort of image with the electron image. On the top here, there's a directly nanofabricated cantilever. Here is from silicon. Here is from silicon nitride membrane. It's made from an Okada here in Edmonton. Since due to we have dual column, you can cut and also view by SEM. You can take a series of image by cutting through your sample. After you stack them together and also do a sort of reconstruction, you will get a 3D image through your sample. Here is a reconstructed image of a glass film. Here you see the top view of some image. Here is a reconstructed result. back to the TEM machine, we have two powerful TEMs, one from Hitachi, one from Joe. Both has very high resolution capability and also the scanning capabilities. Both machine has cooling and heating stage, which you can do sort of in situ imaging and also imaging sample in cryo temperature. And one thing I want to point out is on the Joe machine, which has a very excellent stage, we can do tomography. I will show some image as the next few slides. Due to the very good performance of the electron emitter, can give you very coherent electron beam. You can see this sort of high resolution lattice image routinely with both of machine. Here shows a lattice image of a silicon sample from 110 direction, and also you can see the spacing from those two atom column. You can view at as small as 0.9 angstrom. The other one of the general capabilities, say with TEM combined with FIB TEM sample prep, we can view the cross section of your devices. Here is an molecule electrode from Vick group. They want to see the interface between their molecule layer and also their metal electrode. So the sample is prepared by FIB, showed with a dual column system. Here show the TEM image of this particular region. The silicon is the substrate, and their molecular layer is only like 4 or 5 nanometer. And here is their gold electrode. And also with some other complicated a system combined with sort of a energy loss spectrum, we can identify each layer. Here is kind of polymer and dioxide, and a dioxide here, and it is another polymer layer. Here is a gold.